I'm actually Jim Darby. I'll be the referee, for want of a better phrase, for this session. Richard has asked if we can take questions at the end. So we had like about a half hour, so like 10 minutes at the end, which should be bags of time. Well, actually, it'd be good. The more questions, the better. I will be monitoring the chat during the presentation, though. Right. Okay, Richard. I think it's over to you now. Then.
Okay, I'm Richard Hunt. I teach in Rutland at Catmos College, and this is just one set of experiences combining maths and computer programming in the classroom. It's not a finished article. It's a journey to how to where we've got to now and the next steps that we're currently considering. Very quickly, my background. Um, I don't remember ever touching a computer at school. Computer science wasn't an option. And I was really, really lucky because my folks got me a Dragon 32 for Christmas in 1982. And I taught myself to program in BASIC. And then I moved on to Turbo Pascal and fiddling around with more interesting computing programs. I went to university in the 90s. And although I did maths and stats, I only remember two courses that used computers in any shape, way, or form. But I did get involved in programming up algorithms for a few of the lecturers in maths and science, and they would give me the algorithm. I'd code it in Turbo Pascal or Fortran 77, and that got me a bit of experience. It wasn't until I went and did my master's that I was actually encouraged to program. Which I was taught C. Started using packages like MATLAB, and at that point, I didn't look back. Roll forward 11 years, and after a career in R&D, I retrained as a maths teacher. And the thing that shocked me when I got back into school was maths lessons had hardly changed since I was at school. So why was this a problem? Well, the thing was, there's a really rich overlap between maths and computer science. Not just because some of the topics like algebra and logic are valued by both, but in my opinion, these synergies can act as a prosthesis, not a crutch. Prosthesis is a means of allowing us to do more um, and to solve ever more complicated real world problems. And I could see stuff that we were doing in industry that we could simplify a bit and make into nice examples that we could and nice projects that we can explore in lessons. And it was also just out of step with the workplace. In the late 90s and the early 2000s, I just remember seeing the way that maths changed in industry was dramatic. Lots of different specialist software packages for CAD/CAM, FEA, simulation packages like Simulink and Adams democratized the way that maths was done. It meant more, engineers and just the more general colleagues could do more maths, and it wasn't a preserve of people sat with a pencil in the corner. And we also had it's the first we also saw the generic packages like Maple, MATLAB, and Mathematica with their toolboxes really becoming widespread in industry. And the mathematicians shifted from using pencil and paper to coding algorithms in industry standard languages like C++, like I did, and building on the functionality in these generic packages to do things for colleagues. So life was democratization and life became more interesting for mathematicians. So I was scratching my head and I moved schools in 2010, and the big innovation that everyone was talking about in the schools I was involved in the local area was functional maths being incorporated into the GCSE. This was, and my head of department took this as an opportunity to incorporate more contextualized maths and more group projects into our math schemes of work. This is something that every survey in the college was saying that students wanted more group work, they wanted more contextualized, more real world problems in their maths lessons. And that led me to the Easter egg project. This was an apprentice style project, and basically teams were given menus, they were given formulae, to build and to design, to cost, and to pitch an Easter egg. The idea was the team that made the largest profit won. Now, the pitching was exceptionally competitive. It was done in front of at least, well, quite, on two occasions, 3-year groups. All the teams were there around the sides of the hall, and it was pitched to a local businessman, one of the accountants that I was friendly with, and the school's director of finance. And loads of calculations were done on the fly. And I was quite interested and quite glad actually when some of the students one year came to me and said, "Look, we did it last year. Can we make what they call Easter egg calculators in Scratch rather than relying on their calculators? So basically, press a button, use sliders to set quantities, and it comes out with a value, the build cost at the end." And this was actually chiming with some of the stuff I was reading at the time, whilst I was doing my PG dip in education, because I was reading a lot that was written by Conrad Wolfram about his his computer-based maths project. And I worked partly in Sweden, and one of my Swedish friends put me on to the works by Lance Andersson, and she at Gothenburg University, and she was looking at how using digital technologies changed the way that students perceive and frame problems and the impact and the benefits it can have on their learning. So 2016, I moved to Catmos College, and it was the time that Michael Gore's GCSE curriculum changes were coming to fruition. There were some really important improvements, but like a lot of my colleagues, I felt that the cross-curricular opportunities was between maths and science and the other physical sciences were being missed. And a couple of years later, I started really thinking about what I might offer in terms of a new elective. I'd run since 2016. I'd run the astronomy elective, and the elective program should actually describe is quite interesting. It's really distinctive. It makes Catmos stand out from the crowd. We work a longer college day, 4 days a week, to allow from lunchtime on Wednesdays to be used for electives. So it's an hour and a half session for electives, and students choose 6 electives over the full year, 1 elective per term. And the whole idea is to broaden students' experience and develop new skills to enhance probability, to enhance employability, and also to enrich hobbies and interests. So these short courses, 90 minutes a week, 6 to 7 weeks, and they basically a big booklet comes around and they opt which ones they're going to choose. Normally it's about 20 students, and the students in each elective group can be from year seven right through to year 11. I've run the astronomy elective since 2016. That was oversubscribed, and I was asked, because I've been talking about maths and computing for quite a while in college and what possibly we can do about it, is if I would like to think about running a maths and computing elective in. And that's where the electives really come in, because it's given us as a staff body space to innovate, not just to look at hobbies and things, but to offer something that's a little bit different. So I was interested in challenge. I think maths and computer science are creative subjects. I'm looking at problem solving in real world situations and just ignoring the GCSE curriculum constraints. And this elective, I have to say, it rests on a lot of the conversations I had with colleagues in college, but also many conversations that I've had at conferences. And I went back through my notebook, and the first conversations I had in serious conversations about this were at the ATM conference back in 2019. Now, to give you an idea, to give you a flavor, I should actually explain where my teaching style and strategies come from. I was really heavily influenced by the social constructivists. So knowledge is constructive socially. Learning is a social activity, and the culture that this learning takes place in is absolutely fundamental to success. and our cognitive development comes from social interactions. And my two heroes are Vygotsky and Bruner. And this actually, and I wrote a list because it's possibly at this point to give you an idea of what I wanted. I wanted open-ended problems that and inquiries that students could adapt, take in different directions, and extend. I wanted lots of discussion going on within the elective. I didn't want it to be like a computer science lesson or some math lessons at times where you write something on the board, it's copied down, you use it, and then in a very limited example. It's just not what I wanted. And I wanted the students to share their knowledge, and I wanted them to make use of that what they'd learnt themselves and pass that on to others. Um, there's a really strong link between mathematical reasoning and computational thinking. So we've got the decomposition, we've got the pattern recognition, the abstraction, and the algorithms. And that was sort of poured into a prim approach. This was suggested by one of my colleagues because we wanted to be able to use our computer science lessons as a backup and as a support and as scaffolding for the electives as well. And it's what we teach with computer science at Catmos. You know, you get a piece of code, you predict what's going to happen, you run it, you investigate, you make changes, you fiddle around with it, break it. I really am really keen that students break things and then fix them. And then you make something, and then you use what you've learned to make something else. Now, the choice of programming language was a really major issue. My first thought was I'd use Haskell because I know that's been used successfully in primary schools, and I also know it's been successfully used at A level. Unfortunately, when talking to colleagues, we thought that it would mean that I'd have to do too much of the basics in Haskell before in each of the elective sessions before we could actually move on to do something a little bit more creative. So the idea was for year 11, so years 8 to 11, we went for Python. Python's introduced at Catmos in year 8. That means they do have some familiarity with it, the support from computer science lessons. And also, we still encourage our students to use the TK Inter package, even though this is now beyond the scope of the GCSE curriculum that we use in college. In terms of year 7, I opted to go for the Scratch environment because it's a nice, friendly, block-based environment that reduces the amount of debugging that's needed. The project, and I should say right at the bottom, the theme for all the projects was low floors, high ceilings. And I've read, this is one of my favorite books of all time, Pappert's book. So, and I started thinking back. The first 2 projects were put together with the Search for Prime Numbers and the Mersenne Primes and the Vending Machine project. After doing one of the careers days when I was hosting one of the local accountants, and we had groups of year 9, year 10, and year 11 students coming in for 50-minute sessions. The accountant suggested that we look at constructing some form of income tax and national insurance calculator. So potentially students could actually start to check their pay slips and things later in life. And I also went back to Conway's Game of Life. I remember spending a lot of time in my mid-teens, simulating forest fires. The things that you do, obviously, when you're a teenager. And the thing about promoting the elective, I wrote the elective, the body, you can see the code, the blurb from our elective booklets there. And I definitely use coding and maths lots. And I thought that it would sort of it was aimed initially to attract the more able students, those students who you normally refer to as used to refer to as G&T and maths and computer science. But that's not what happened. That was big surprise right from the very beginning. And we had students from a very wide range of abilities joining and in different places on their learning journeys joining the elective. And that did change the way that some of the things were done. The aim of the elective was to offer something beyond the usual secondary curriculum experience. Right. The pilot took place just before Easter this year. I'd done 2-day-long pilots with the start with the back in the autumn with the search for prime numbers, and I'd taken what I'd learned from that and produced a set of PowerPoints to go with the pilot. And I'll come to the PowerPoints in a minute to give you a little bit of idea of what's there. It ran over 6 weeks. Instead of 20 students, we had 45 students putting themselves forward, and another good 20 odd saying that they were really interested in doing it, but they were going to do D.A.V. I'm still amazed. I still am amazed that we had 45 put their name forward for an elective that was brand new and nobody knew anything about. It was wide ranging. We whittled them down to 36 year 8 and year 9 students with a promise to the year 10s and 11s that they would be they would be in term 5. It ranged between absolutely zero Python. I had a student who was very new to this college, and it said basically he literally never touched a computer except to use Scratch or email. Right through to year 9, we run an academic scholarship program in college, and some of the year 9 academic scholars came and joined the elective. And 2 projects were the prime numbers and vending machine project, and because of the size of groups, we ended up with 2 computing rooms, and this actually changed the whole dynamic of how I was going to run it. Because I'd imagined one of the computing rooms with groups into corners. We had one really long computing room, and another one set to the side, so they were at least side by side. And one of my maths colleagues jumped in to support me because it's many more than what we were expecting. And we also got a A-level computer science volunteer from Harrington, which is our 6th form in the Federation. Now, because of the way this worked, you literally, because of the design of the computing rooms and because they were side by side, what we very quickly started doing was gathering students around either a whiteboard, the old style ones you do it write on with a pen, or one of the interactive whiteboards with my computer my laptop plugged in at the side. And that's how we'd start the elective sessions. We'd come back and gather in groups again from time to time, and we'd finish each session back in the group. And that was basically talk about what we were doing, think about any concepts that we needed. I used that for explaining about iterators, thinking about how different concepts. So for instance, difference between arrays and lists, which in Python, even my year 9 computer science scholars weren't aware of. And then we'd set off with a set of tasks and we'd go away. Now, the tasks originally were written on the whiteboards for students to have a go at and to add to, but that's because of the layout of the rooms and people were running at different students were running at different speeds. I decided to start really incorporating more detailed instructions into each of this for each step in the slides. So, for instance, I've given 2 examples from Aristophanes' sieve, and that's the method that we used for coding up for the search for prime numbers to start off with, and we used a glorified version of that. None of my code fragments are optimized code. I have to say that they're code that is generally intended to be easy to understand or easy to experiment with and pick apart. the thing that so I'll just go back because there's something else I just want to underline. Um, if a student, if the uh, my academic scholars would quite often go away and ignore the instructions to start off with and start building and experimenting by themselves. The year, the year nine, the other year nines and the year eights, some of the year eights would look at the instructions and then riff on those instructions. But what I found was with some of the year eights in particular, I ended up with a horseshoe round one of the interactive whiteboards, and it was they like to program along. So we'd literally construct the code together. And I'd say, well, what's the first thing we've got to do? And we would decide it might be to create the list. So we'd talk about what to call it, what we'd actually need to type, and then how we're going to populate that list, how we're going to initialize it, what sort of iterator we'd use. And also to simplify things, I kept them away from using lots of embedded if-else statements. We tended to go for, where possible, just simple if statements to keep the code a little bit more simple. And also, it actually showed that it didn't matter which of the students, where the students were on their learning journey, they were really hesitant. A lot of them were really hesitant about making mistakes and having, because they thought mistakes apparently are bad. I was told by one of the students. But that's not the pressure that we put on at Catmos. We encourage students to take steps and to push themselves out of their comfort zone and to play with ideas and see what happens. And that's because that's how we learn. We learn by making mistakes, and we learn by talking to each other and sharing these mistakes. So for terms 5 and 6, term 5, this had the 10s and 11s in for term 5, and then term 6 I'll come back to in a minute because that was quite an interesting one. I was determined that I was going to get the groups a little to mingle more and to communicate and to talk more, especially between the different age groups, because term 5 went through from year 8 through to year 11, and term 6 was years 9, 10, and 11. Both of these were oversubscribed again, and this wasn't anything of my doing. It was literally word of mouth from students who had been on the term 4 elective. So I was experimenting on how, and for the first 2 sessions, it was literally a lottery. Which groups they came in, picked a ball out of a pot bag. The color of the ball determined which group that you were going to work with that day. That was a little bit, the first time that happened, students were a little bit wary, but it actually was good. It broke down some barriers, and I was really pleased with that. And I found that the sharing when we were talking as a group actually did improve massively. I also went for more of an extreme programming style, where basically you're working in 2s or 3s. You break up, you decide what functionality you're going to code first, go for the easiest, the low-hanging fruit, and you keep everything simple. And then you bring stuff, you share what you've got, you test it, you might make changes, you refactor it, and then you go and you agree on the next steps. That was quite a successful idea. And also, I was also putting extra little bits of notation and removing some of the sentences from the guidance for building the algorithms. We also introduced more process flow diagrams, especially this was really helpful for the vending machine project and for the income tax calculator, and some very basic use case diagrams as well. So, and would I do this again? Yes, I am going to do it again. It's just that the form of it is going to be, it might be slightly different, and I'll try and explain why. I was massively pleased about the take-up. Really, the interest I've had students, it's not running this autumn because to make space for the astronomy elective to run. So it's not running through to terms 1, 2, and 3. So I'm having students come in and asking, when is it going to run again? I had a wider range of abilities. The students with massive variation in targets, right through from students who predicted grade 3, grade 4 for computer science through to grade 9, and the same for maths. one of my concerns was it would attract more boys than girls. That was not true in the slightest. Um, most of the groups were about 60-40. The first two were in favor of the boys. Second, the last one was actually there were more girls than boys. There was actually almost three-quarters of the group were girls. I want to make it more challenging and more enjoyable. So with more ideas from the building more projects, and I've had a couple of suggestions about what some of the students would like. Um, and also the thing that really, 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 it's I feel sometimes I feel a little bit emotional about it, but is the amount of enjoyment that a lot of the students got from it and the confidence growing. And one of the chaps from year nine, I'm definitely trying not to mention his name, came up to me in one of the first sessions and said, nothing's ever worked with a computer for me. And I said, well, we'll try and make that different. Um, you make sure you ask me lots of questions. I'm always here to help. I've got another Harrington volunteer. I'm sure we can do it. At the end of the third session, he came up to me and he wanted me to see what he'd actually put together. And it was the Mersenne prime. It was the Mersenne search for Mersenne primes. So he got the prime number search to work. So that they have a stuff in his sieve. It wasn't. He'd actually gone the next step, and he'd got the next Mersenne prime. Not the one that I gave him, the one that's 8,183. And the amount of pride and confidence that he came away with, that was the thing that really made my day. It made my term, to be perfectly honest. Because most of the students in year 8 only had one term of Python when we started in term 4, you can't skip the basics, and I don't think we can skip the basics even with year 9. So I'm thinking about putting together some sort of reference guide so they can look at the different concepts. So look at the functionality and the way that you would use a list or array. Look at different types of iterators, because I deliberately went for one, but we can actually make the code so much more efficient by just a little tweak to those iterators. And I know quite a few of you already spotted what it is. And to describe I need to describe the features of the code in a little bit more detail. I think that would be a big thing. And also, it's debugging to building student skills with debugging. We use Thonny as an IDE right across all our GCSE groups. It's a really nice student-friendly IDE, sorry, but students weren't used to using the shell to test their code, and that's something that it took a little bit of getting used to. You build a piece of code, you can press the go button at the green arrow at the top, and then you can call your functions from the shell and see what happens. So there's more opportunities for creating test harnesses. And I think if I'd actually supplied test harnesses for the first project, I think that's the Primes and Mersenne Primes project, I think that would have sped up progress a lot. But yes, debugging skills. Now, big change is to do with how I think it would run and where I think it would run. The big innovation for electives this year for 2023 is that we're now, instead of having vertical electives, we're going to horizontal electives. What do I mean by that is your key stage 3 are in one group of electives, key stage 4 are in a different group of electives. It does cut down, it would cut down the amount of it would make it difficult because I wouldn't have year 9s to help year 8s with their experience. And that's something I'm still thinking about how I get around that. And year 9 and 10 computers scholars wouldn't be an issue, but other year 9, 10 students would be. So, but also I'm more strategies for mixing mixing up the groups and the ability and different places in learning journeys within teams. That's still a work in progress. So where next? The elective is definitely going to run later this year. It's probably going to go to once or twice a year. Students nominate themselves or say that they're interested, and then we'll invite students in. That will allow us to mix up friendship groups a bit better, a bit more easily. Although I will say that we haven't had any behaviour issues at all with this. So it is a really nice, relaxed way of running something, because it means you can concentrate on what we're building, and you're not doing behavior management. The routines very quickly fall into place, where you gather, discuss, you go away, try something. If it doesn't work, talk to the people beside you. It doesn't work again, get some help in, and then get hold of me or my colleague. Different versions for Key Stage 3 and Key Stage 4. I still start with the prime search for Key Stage 3 and Key Stage 4, but I think I'll be looking to extend it and possibly into breaking RSA code with simple put together, simple messages encoded with short prime numbers, the ones that not very many digits. There's potential to run it as an after-school club as well. It's not like my old school where 82% of the students bust in and out every day, because we're on the edge of a small town, and we've actually got service buses to the local towns as well. So that's something that I'm exploring. That would take the pressure off to do 2 projects in 6 weeks, and it would also change some things slightly to make it a little bit more relaxed, and perhaps we could actually follow more. Students can direct it a little bit more and influence the direction of the project. And we've already got 2 new spin-offs. There's a spin-off elective that's been run by my maths colleague focusing on data science, and it's trailblazed, and we've now got a robotics. We've got a robotics elective up and running this term as well, which is combining maths and computer science, basically for controlling robots around a course to start off with. And then we're talking about building a very simple robot that we could calibrate to just move small blocks around, on a desk or stood on the floor across a small area. And if anyone's still awake after that, thank you. I'm happy to take questions, or here at the panel. If anything, if I said something that doesn't make sense, or you just want me to elaborate, please do. I'm happy to answer.
You might need to take yourselves off mute, because I think most people are on mute to avoid, I don't know,
Right.
dogs barking or children or whatever.
Yeah.
Or slurping of coffee in my case.
Can I just have a drink of water?
We did have one question in the chat, which is actually quite an interesting one. So the best place to answer it was in the chat, which is about the Thonny IDE. It's THONNY, and it's much easier to spell that out in the chat than it is
Yes,
verbally.
it is.
That comes with the Raspberry Pi pretty much as standard.
Yes.
For those of you who actually quick search, so it's convenient to have the shelf. People can see my picture, but that is a Raspberry Pi Pico,
Yes.
which you can get for very little money. They're about £3-4, I think. Runs Python, and using the Thonny IDE, you can actually upload your software. That one's in one of the packages. I've probably got one lying around somewhere that's not in the package. And that actually runs Python on this tiny little board. And I'm quite a fan of things like that. And that ties in with the robotics, for example.
Do you want me to see if I can stick the idea up? I might just be able to do it.
Yeah, that would be good, actually. I'm just thinking, I've got it, but not on the machine I'm running Zoom on.
If I stop the share, hang on a sec. Just give me a moment.
I'm searching around. I knew I had one. Welcome to my desk.
Right.
That's what we're talking about. That is actually the hardware you can run your Python on. And it's a little board, and you can get these for £3 or £4 each. they're basically handable outable to students, which radically changes the whole attitude. You know, you can sit there and say, here it is, you can take this and take it home. You can also plug in flashing lights and stuff to it. I'm a great fan of physical computing.
Yes. Right. Okay, I found it. I've got it up and
Brilliant.
running. Let's see if I can share it. Just give me a moment. Hang on. Thorny, let's see if this works. Right. Can you see it?
Yeah, we can. That's brilliant.
Brilliant. The really nice thing about the Thonny IDE, and this is the Mersenne, this is my code for the Mersenne primes. It's not optimized code, but the thing that's really, really nice is this assistant. And basically it comments on your code. So let's go and break it. Right, let's go in here. Just stop it. And hang on, let's see let's break it. If I just do that, run this, that should be analyzing your code. If it's not working as usual, oh,
It does actually work. I was looking at that now because
yes,
you've just made it less efficient, which is quite
yes,
funny.
it does. It is really interesting. Let's just give it something that it's not had. Sorry, my dog is having a big dream over there at the minute.
I think this
Yeah.
is quite interesting. What I like about this environment and why it's very good for education is it's really clear and you can do things and you've got like comments down the bottom. It's everything you actually
Yes.
really want.
Hang on.
And
I know I'm going to break it. Hold on. I've got an idea. I'm just thinking of the mistakes I've seen recently. I'm just thinking, so if I do this, let's see. Let's see if this works. Analyzing your code. No, I can't. I just want to break it.
that'll give it the wrong answer. Do something. Put a +10 on in there, so it'll
Yeah,
go past the end of the array and
yeah,
just see
that'll
what
do.
happens.
Yeah, there you go. So if I make this, so it comes back, you get your trace back. But the really nice thing is out of rate, it tells you where the mistake is, index error, list assignment, index out of range, line 25. And at that point, you can start working out what's going on. And I think that's really nice. I show you. So at that, and now you can drop in your debug. My debug, right, can I move this? I've got come on, here we go. Drop this in, and then we can run. I'm gonna go step.
But this is the interesting thing, I think, is that students can go in and see how
Yeah,
it's working.
and that's
I'm
step.
surprised no one's jumped in because of all the talks in this track. This is the one that uses Python. People then move on and use Haskell later
Yes,
on, and that's quite an interesting comment.
yes.
Um,
And then you can go around and step and just. I tend if what I must admit is what I get students to do at this point is put a print statement in. So if I would get them to start printing out the value of K and then going around the loop to seeing what happens. But you've got loads of data and information. I'm happy to do a proper debugging talk at some point.
right, this is actually quite interesting. We've got a question come in. What do you
Right.
think if I could use this idea as a project-based learning idea to incorporate some math concepts as well as to some extent literacy for year nines? I think this is quite good because we talk a lot about prime numbers. What do they actually mean? What do they do? And why do I need to know? So this is a good way of talking about what makes a prime number and how can we find them.
Yes.
I quite
Uh,
like that as a concept.
yes. And the way this is, can I just unshare again? And I'll go and grab one of my PowerPoints as well because I think this is a really useful. this is a really useful thing um, for broadening um, and making links. I read.
Mm.
Hold on. I'm just going to grab this one, see if this works. Half a sec. So where possible, hang on. Just I'm going to try and share again. It should. Does that? Yeah, right. Is that? Can you see? That's coding elective. It should say part three. Does that work? Does that work, Jim?
I can see part three,
Yeah.
civil eratosthenes. Yeah.
So we start by discussing, we start by going in and discussing what prime numbers are. Because the first couple of parts of it are to do with using lists and calculations and storing the information, the results in lists. Um, so we go through what a prime number is, and then literally old style, get a piece of paper out, here's your grid, go through, use the civil Eratosthenes, and then it's to start to think about what's going on, get them to discuss what is going on. All the discussion is really, really important. It goes right back to what I believe is the root of teaching, and it's teaching and learning is all social interaction. It doesn't
Mm.
really matter who the knowledgeable other is, as long as they are that person who has got the knowledge. Um, it's all about discussion, and that's how we learn.
Yeah. I would add to that I get into quite a few discussions because I always maintain that maths is the subject that is most important to be talking in
Yes.
during class.
Um, and there's been a couple of quite nice what is it? It's School 21 in London. They've I've seen a couple of nice presentations from them about their oracy project and the use of their championing of oracy in science, maths and sciences as well.
Right. I noticed that we're pretty much out of time. So any last questions? Oh, does every student have their own computer? How does this work?
Sorry,
Everyone's coming up with really good questions just as we're finishing. This is very sad.
can we
Um,
keep them for the chat for the panel at the end?
Actually, yeah. Does every student have their own computer? In our school, yes. I don't know how the people did it, but they managed to get hold of a shed load, absolutely mountains of Chromebooks.
Yes.
And discussions about Chat GPT et al. That will be really interesting. Mars, I think that's a very strong discussion for. I think we've got some sessions later on. That's a really good one.
Yes.
Um, but
For
I
our point, yeah.
so I quite passionately believe this bit because the school that I actually volunteer in is in a quite a deprived area. We've got well over half the students have free school meals. And if you can't afford a resource, it may as well not exist. So that ties in very strongly to Cynthia's comment about students have their own computer.
Yeah.
That's why we've got loan Chromebooks.
Yeah. Um, we're lucky. We are really lucky that we have got four full labs of with workstations in the college.
Mm.
We've also got our breakout areas. Every subject group has its own breakout area, and they've got about 20 computers in as well, workstations. We are very, very lucky. And also, one of the reasons we stay open till 5 in the evening is all right. We live and work. I live and work in quite a leafy middle class area. Is there's a lot of students in and around the local towns in particular who do live below the poverty line here, and so they can stay in college until 5 and use the equipment during lockdown. We got a lot of our a lot of our workstations out of the college and into students' homes on loan agreements.
I think that's quite an important thing. You need access to this.
Yes.
Right, we're past it. Any other questions? I'm awfully sorry, Miles. You had your question about chat. Right. Okay. I've just got direct. Miles asked a very interesting question in chat, yeah, about Chat GPT. We have a panel at 5 p.m. today on Chat GPT. session F1, I believe it is. Ian's just said in the chat, and I think that'd be a very good one. I actually asked some of the maths teachers at school. I sat there and said, I asked them, right, in a world where Chat GPT can probably pass GCSE maths, what should we be teaching and why? And that's quite an interesting question.
Yes.
Like, any last minute questions? Because we're already nearly 5 minutes
I'll stop
over, but that's a
sharing.
good thing, I think.
I was just going to go and see if we can. How do we download? Can we download the chat so we can get the questions?
I don't know. I think we discussed most of them already. You said project-based learning. Yeah, I love project-based learning. I know it's out of fashion at the moment, but I think it's brilliant.
Yeah.
This is strong personal experience.
Yes. Right. Is that it? Are we done? Have we got to make space for the way for the next people? Next
I,
room.
I don't think they're reusing the Zoom rooms, but